making a V-Block. It's something that we use at work and machining. I had a small SPM, and I dimensioned it out with just calipers and on Autodesk Fusion 360, and now I'm printing it. It's like we're about halfway. There's the finished model. Pulled up here. Here's some projects I've been working on. Here's something I invented. It's an outlet extender. Basically, can go in a door, and that way you ain't got to shut your door on cords anymore. Pretty cool. Yep. And that arose from, I was working outside and I didn't have any outdoor outlets, and so I kept having to shut my door on my extension cords, and so I ended up designing this, and that works. I printed it off, and it's amazing. Pretty neat. The patenting process is overwhelming, but anyways, fun times. I made this last night. Made this little radius gauge. It's in the works of making a revolver. There's all kinds of stuff I made. I got oh, here's what I am printing right now. So it's just a V-Block used in machining. I actually wrote V-Block on the side of it too. Let's see if I can get it up right. Nope. Rotate it. There you go. There's actually depth. See, it actually goes down in it. Here's I have a small refrigerator at work. It's lockable. I've been working on a key for it. I made one already and it worked, but I'm working on making it more nifty. Maybe put a hole here, put it on a keychain, and I gotta make this. I gotta blend that on in there to give it integrity. I can show you guys an example. Like if you wanted to make a hole here for like a keychain, you can go up here to create. Just go down the hole, click on your surface right here. Okay, obviously I don't want a 300,000 hole. Keychains are very small. Back that off. Let's say 125. There you go. And you can move that hole anywhere you want it. I'd probably want it about around in this area. And hit OK. And there you have it. That's how easy. I love Autodesk. See that? Cut the cost. It doesn't take much anyways. But this wrench was designed. I actually got another one I want to make it. Go ahead and make that a solid. And but that wrench was designed specifically for this bolt. There's a piece that goes in there, and that piece is right here. So that bolt, this goes inside that bolt, and that wrench is used to tighten it down into this right here. This is something I designed, and I printed it out and it worked. Beautiful. Worked excellent. So come a long ways with the software. It's Autodesk. It was very stressful in the beginning, but I had zero experience and I just stayed at it, and I got very good at it. I mean, it's just basic stuff to me now. I'm working on learning how to make prints. I'll pull that up, let you see it. GD&T, geometric dimension and tolerancing. Learning all that. That's important stuff. That's what makes things fit together real nice. Whenever you get stuff that's dimensioned out. What's going on here? Drawing views. Where's that? There it is. So basically, you know, you got your widths and all that. And like A, drawing it, you know, it shows what it is. It gives you your dimensioning, where it's located, from where, you know, pretty neat stuff. So, drag this thing over so we can see it. Pretty cool. Put a little effort into it. So, my stove knobs, the knobs on my stove messed up on me, and so I just made new ones, printed them out, they work. There was a special design on the bottom that had to be made, a diameter and then a flat, you know, and so I had to make sure that was right. And this printer is accurate. It's within 15 thou, I believe. I believe I've gotten it down to 7 thou, within 7 thou of what I dimensioned it out to. But you can, that's all done with speeds and feeds, you know, and make name tags, different things, you know, just whatever. Those are cool for keychains. And just different stuff, fun stuff. This is something I was reverse engineering, kind of like that key. It's a little flashlight at Walmart for $1. I just took it apart and said, hey, I wonder if I can do this. And so I started measuring it out and working on it, and I got the back side of it done, and come out nice. You put your little batteries in there and whatnot. Pretty cool. So that's what I've been doing with my life. Looks like this is coming along. This printer face is really neat. It tells you how long you got left. You know, it says I got about 57 minutes remaining. Or is it 18? Estimated 18. So, pretty neat. It tells you your bed temperature. The heat of the extruder is 210. Bed is 75. You got your axis. It's 3 axis. X, Y, and Z. And then you got your extruder. Extrude. Whatnot. And you can actually go in here and modify the code if you want to change something. It's really cool. So if you've ever ran a mill, it's basically the same thing. Very simple. But here it is. It's coming out with the bevel now. It's starting to come together. And I'm going to go ahead and turn this off, and when it gets ready to be done, I'll go ahead and start this. Looks like it finished. See if I can't get that off there without screwing anything up. So there's some things that need to be cleaned up, as you can see. So let's take a look at it and talk about it. So the reason why that looks so good there and not as good there is because that down in there was printing in the air, And so it had to basically web its way until it became a solid. And eventually it did, and it was able to make a nice finish on this side. But because of the depth, see how it goes down? That's the reason for this, because as it was printing up in height, it was laying on there like that. As it was coming up, and when it was coming across through there, it was just printing in thin air, and so the string couldn't make good contact with all sides. That's the issue, and that's what other things are for, like your where you get into supports, and there's other filaments that's like can be dissolved in water or alcohol or whatever, and it's basically designed for that. It will do that for you. And but if I would have printed this like this, I wouldn't have had that issue as bad. There might have been a little bit up in the top there, I doubt it, but it would have come out nicer. But for the purpose that I had with this, I wanted a very, very smooth finish on top, and that's what I got. And one good side for sure. All the sides came out nice. Everything was perfect with this. It's set for that. And what I can do is just clean that up, get a little small tool and go in there and clean that trash out of there. You know, get those holes nice and pretty. And yeah, there you have it. A miniature V-Block. This is not to scale. Anytime I print something, I never print it to scale the first time, especially if it's bigger. You know, the actual V-Block that I used was quite a bit larger, so this is like a mini version, just a test piece. It was going to take like 6 hours, you know, and this one here only took like an hour, so you know, there's going to be a big difference. So now that I know that it works, everything's good, I may go ahead and try it. Now on the next one, you know, it made it across there nice, but the next one is going to struggle more because it's going to be, you know, obviously, you know, a bigger piece would mean wider gaps, and so it would be harder to bridge. So it's going to be interesting to see. You know, I may have to end up building it this way, so that way I won't have that issue inside of there. And so I may print another one of these and rotate it to where it prints like this, just to see how it comes out, just to see. And if I get a nice finish there, then hey, you know, that would solve that problem. So trial and error. I love it. Thank you guys.